Hello, and welcome to day 10 of learning backend development from ChatGPT. So let's get started. So in the last lesson, we looked at just authentication and JWT, authorization, and the bcrypt for like hashing our passwords, and with the salt, so that like even if two users had equal passwords, like they wouldn't be the same hashed password. So let's see what we're going to solve for day 10's lesson. Okay, day 10, securing APIs. Preventing common vulnerabilities, so SQL injections, XSS. Okay, so please give me day 10's lesson. So we're 2/3 through this, I think. Yeah. Okay, let's see how we can secure APIs. So API security ensures that only authorized users and applications can access and interact with your application's data and resources. It's essential to understand and implement security best practices to protect your API from unauthorized access, data breaches, and vulnerabilities. So securing endpoints. Ensure sensitive endpoints, e.g. user update or orders, are accessible only to authenticated users. So input validation, prevent SQL injection and cross-site scripting, attacks by sanitizing and validating user input. So rate limiting. So protect against DOS attacks by limiting the number of requests per user or IP. So securing an API involves setting up checks and constraints to guard against unauthorized access and common vulnerabilities. For example, in an e-commerce app, endpoint site admin dashboard should be accessible only by admin roles. An input site username or product details should be validated to avoid malicious code injection. So middlewares in Express.js can intercept requests and apply checks before they reach the main root logic. This is useful for adding authentication and authorization to secure sensitive routes. So, for example, authentication middleware ensures that only authenticated users can access certain routes by verifying their JWT token. So JWT equals required JSON web token, secret key equals your secret key. Then we can do authenticate token. So this is what we saw yesterday in the last lesson. So token equals right ahead is authorization. If we're not finding the token, we're gonna say access denied, and we're going to verify if there's an error. It means that it's an invalid token. Otherwise, we're just going to do we're going to set the user as user because it's a valid user. Then we can do app.get dashboard. So with our middleware, we pass through that before it can happen. So authenticate tokens, middleware, and yeah. So dashboard, welcome to your dashboard. So then authorization middleware checks if the authenticated user has the correct role to access specific resources. So const authorized role equals role, so it's another middleware one. So we're going to return the request, result, and next function. So if the request is user role is not equal to role, then we're going to say access is forbidden, and if not, we're going to do the next. So this, basically just what middleware is. So the authenticate middleware checks the presence and validity of a token to ensure the user is logged in. Authorized role middleware checks the user's role to restrict access to specific endpoints based on permissions. So implementing role-based access controls, RBAC. So role-based access controls, RBAC, allows you to grant or restrict access to resources based on the user's role, e.g. admin, user, or guest. So setting a user's role, so we can have a user schema. Oh, so this is what it was on about yesterday. So we don't actually create a new user schema, we can do role. I see. So role-based root protection, use the authorized role middleware to restrict access to resources. So role is going to be default user, and you can use the authorized role middleware to restrict access to specific resources. Okay, and then authorized role must be admin in order to access this. Yeah, okay. So preventing common vulnerabilities, SQL injection, XSS. APIs are vulnerable to attacks like SQL injection and cross-site scripting, XSS, if inputs aren't properly sanitized and validated. Example, SQL injection. Issue without parameterized queries, SQL commands can be injected into API calls. Solution, use parameterized queries or ORMs like SQLize or Mongoose to sanitize inputs. So db.query, select everything from users where ID is everything. We can pass in the parameters of the request's ID. So this is the parameterized query. If there's an error, throw the error. Otherwise, we get the results. So cross-site scripting. Issue malicious scripts injected through inputs can execute in a user's browser. Solution, use libraries like XSS Clean to sanitize data and prevent scripts from being injected. So we can install XSS Clean, and we can just do app.use XSS. So parameterized queries prevent SQL injection by treating input as data rather than executable code. Libraries like XSS Clean sanitize the input to prevent XSS attacks, removing potentially harmful characters of code. Okay, so let's go into the extra challenge. So set up a rate limiter using libraries like express rate limit to restrict the number of requests an IP can make in a given period. Okay, so it hasn't actually taught us that for some reason. Okay, I'm just going to... Please give me... Oops, sorry. Okay, let's see how you do this. So I reckon this is pretty important. So to implement this, we can use express rate limit, so we install it. Oh yeah, we just do express.use. So 15 minutes max. Too many requests from this IP. Okay, do we just do app.use limiter? Okay, I see. Customize rate limiter. You can apply the rate limiting specific routes if you only want to protect certain endpoint routes. Okay. So yeah, that's all for today's lesson. So thank you for watching, and I'll see you in the next video. Goodbye.